In today's lesson, we're going to be talking about geometric sequences. A geometric sequence is a sequence whose consecutive terms have a common ratio, which we're going to call r. Here's an example. We have the sequence 12, 36, 108, and 324. If you think about going from 12 to 36, you can multiply by 3, and from 36 to 108, multiply by 3, and 108 to 324 is multiplied by 3. A quick way to check that common ratio is to divide consecutive terms. If you take that second term divided by the first term, you get 3. If you take the third term divided by the second term, you also get 3. We have a formula that illustrates the nth term of a geometric sequence, and that formula is an equals a1 times r raised to the power of n minus 1. So within the formula, we can think about an representing the nth term, a1 represents our first term, r is the common ratio, and n, remember, is that counting mechanism. N represents, 1 represents the first term, 2 represents the second term, so on and so forth. Here's our first example. We'd like to find the formula for the nth term of this sequence. Well, first, let's double check that this is a geometric sequence. As we go from 160 to 180, and from 80 to 40, and from 40 to 20, that common ratio is a half. Each term gets multiplied by a half to get to the second term. And remember, we can check that by dividing consecutive terms. If we divide like 20 by 40, that equals 1/2, and that should work for any consecutive terms. Our formula is an equals that first term, 160, times the common ratio raised to the power of n minus 1. And you can always double check that this formula works by plugging in any of the n values and checking that you get the correct term. For our second example, we're asked to write a formula, then find the 12th term of the geometric sequence. We have 46, negative 162, 54, and negative 18. So first, I'd like to find the common ratio. Well, it's not really easy because we have some bigger numbers from the first to the second term, but remember, we can divide any two consecutive terms. So I'm going to choose to divide the two smaller numbers. Negative 18 divided by 54, if we simplify that, we get negative 1/3, and that's our value of r. I'm going to write the formula. The nth term of this geometric sequence is equal to the first term, 46, times that common ratio, negative 1/3, raised to the power of n minus 1. The second part of the question is asking us to find the 12th term. So we're trying to find a sub 12, the value of the 12th term. Well, we can just plug 12 in. 46 raised to the negative 1/3 power to the power of 12 minus 1. Well, I know that raising negative 1/3 to the 11th power is going to be a pretty big number. So I'm going to use my calculator for this next part. I'm going to take 486, multiply it by negative 1/3, raised to the power of 11, and we get this decimal answer. I'd like to put it in fraction form, so we can press math. Number 1 is fraction, press enter, enter, and there we have our answer, negative 2 over 729. So the 12th term in this geometric sequence is negative 2 over 729. And here's our third example. We're given that the second term of a geometric sequence is negative 18. A2 is negative 18. And the fifth term is 2/3. A sub 5 is 2/3. And our goal is to find the sixth term, a sub 6. There's a couple of different ways that we can approach this, but I'm going to use an algebraic technique. So using our formula for the nth term, I'm going to say that negative 18 is our second term. That equals the first term, which we don't know yet, times the common ratio, which we don't know yet, to the n minus 1 power. Well, the value of the term is negative 18 when n is 2. So we can plug in 2 minus 1 right here and simplify. This just becomes r to the first power. I'm going to write another equation using the other piece of information. 2/3 is the fifth term, and that equals the first term times that common ratio raised to the power of n minus 1. Well, the n that corresponds with 2/3 is 5. And if we simplify there, 2/3 equals a1 times r to the fourth. Now what we've created are two equations with two unknowns, so we can use substitution to solve. I'm going to isolate a1 over here. If I divide by r on each side, I have an expression negative 18 over r equals a1. And I'm going to take that and substitute it into the other equation. So now I've got 2/3 equals a1, which I'm substituting negative 18 over r in, times r to the fourth. I'm going to slide the paper up to make sure that we can see what's going on here. So here I have an equation to solve. I've got it down to a single variable. I've got it down to all r's. And I'm going to simplify 2/3 r to the fourth. If we put this over 1, we can see that we can cancel one of these r's. So it becomes negative 18 times r to the third. To isolate r, I'm going to divide on each side by negative 18, which is the same as multiplying by the reciprocal. And then we can reduce 2 and 18 becomes 1 and 9. So we get negative 1 over 27 equals r cubed. To solve for r now, I'm going to cube root both sides. And the cube root of negative 1 over 27 is negative 1/3. So we've found our common ratio. Now that I've found the common ratio, I can go back to this step over here and plug in r. Negative 18 over r, which is negative 1/3, equals a1. And negative 18 divided by negative 1/3, the negatives will cancel. We can multiply by the reciprocal, so we're essentially doing 18 times 3, which is 54. Sorry, the negatives cancel. This becomes positive. Positive 54 is our first term. Now that we know our first term and our common ratio, we know our first term, we know our common ratio, we can write our formula. For the nth term, the nth term is the first term times the common ratio raised to the power of n minus 1. Finally, the question is asking us to find find the sixth term. So at this point, we can go ahead and plug in 6 minus 1, which is 5. So we've got 54 to the negative 1/3 raised to the power of 5. I'm going to use my calculator to finish this out here. And we've got negative 2/9. That's our final answer. That's it for our lesson today on geometric sequences.